Okay, Jai Hind everyone. Myself Achintya Pandey, working as assistant professor in Department of Information Technology at Ajay Kumar Garg Engineering College. So today I'm going to discuss string matching algorithm. Okay, so the objective is to explore the concept of string matching algorithm. So what is string matching? String matching basically there are text string, there is some pattern, how the pattern goes to fit into the string, what the pattern. Okay, so string matching algorithm, it basically try to find a place where one or several string which is called pattern are found within a text. Okay, so let's discuss how the string could match with the given string. Okay, just by example. For example, we have a say text array of size n, pattern array which is of size m. Of course, m will be less than n, then n only, or m may be equal sometime n. Okay, so element of p and t. Okay, for example, that is subset of sigma. Sigma is set of symbol. Okay, so the algorithm, I mean how the pattern could match with the text string. Let's just have here sigma is just the set of symbol. Okay, like for example 0s to 9 or ABC or PQR or alpha beta gamma. Okay, so for example, suppose this is the string of length 13 is given ABC, ABAA, BC, ABAA, and given a pattern ABAA. So how we'll find that this pattern is going to match in the string or not? So what will we just start comparing with the first character of the pattern with the first character of text. So if the whole true for all, I mean character of the pattern, and the whole I mean this text, or you can say the whole characters be found together in the given string, then we can say that this pattern this pattern is matched in the text. So just see the process how we can start. For example, this is 1 2 3 4, so we just going to match. A is match, yes, then we will match the second character. B is going to match, yes, there is a match, but this third character and the third character of text is not going to. There is A, there is C, so there is a mismatch, so we can shift the pattern by 1. If we get the mismatch, okay, of any character or corresponding character with the corresponding character of the corresponding character of pattern with the corresponding character text, if we get just a mismatch, then we will shift the whole. Okay, so we can shift the pattern, the whole pattern by 1. Okay, so just shift by 1. This is the shift equal to 0. We just started, and if we shift the whole pattern ABA, so we start match. So here first character of pattern A is just mismatch, so again we will shift, S becomes 2, then we will see here the first character is A, while in the text it is C, so there is a mismatch. So again we will shift, the S become 3, so here A is matched with A in the pattern A, in the text A, yes, there is a match. B in the pattern it is B, and in the text is also B. Similarly here third character A in the pattern and the sixth character in the string, I mean text A, and similarly the last character of the pattern which is A, and the seventh character of the text is A. So the whole, I mean pattern is being matched with the text, so we get the right place. I mean after S equal to 3, or we can say at shift 3 we have a match. Okay, similarly when S equal to 9, there will be another match, again we can shift. Okay, so the first match is going at S equal to 3, and the second match again we have ABAA. So this become again after s equal to 9. Okay, we will again shift the whole, I mean s equal to 3, then 5, then 4, here 5, 6, 7, 8 and 9. So we have seen that at 9th position there will be another match. Okay, so by that way we start doing the process of string matching. Okay, so we can formalize the process of string matching. So there are popularly so many algorithms. Out of that, Knuth, Morris, Pratt, and this is very popular, I mean, method of string matching. So there are 4 algorithms for string matching. One is Navy string matching algorithm, second is Robin Karp string matching algorithm, and third is Finite Automata string matching algorithm, and Knuth, Morris, Pratt algorithm, KMP algorithm is there. So in KMP, the time complexity of matching the pattern with the string and with the text is order of n. Similarly, here in the automata, it is also order of n, but in the nav and Rabin cap string match algorithm, it is order of n minus m plus 1 into m. Okay, so of course we can say that here time complexity is less, so it will be more preferable. So what is the nav string match algorithm? Just we have seen how we have started here. This is the nav string matching algorithm. What we do, we just start match with the first character of pattern with the first character of text. If it matches the whole text of the pattern, then we can say there is a match. So just we can formulate the process in the algorithm. Okay, so nav string matchers, we have passed the text, and this is the T is what text array, and P is what pattern array. Okay, I mean we have just passed the T and P. Okay, means first character address. Okay, so in the value of n, we have stored the length of text. In variable m, we have stored the length of P pattern. So what we have started, just we have seen for s equal to 0 to n minus m. Okay, so we just what we do if P1 to m is whether equal to Ts plus 1 up to s plus m. If corresponding character of the pattern match with the say at particular shift the corresponding character of string, then this is there is a match. Okay, so the time complexity will become n minus m plus 1 because maximum n minus m plus 1 time it will run. Okay, so just here see we have already AB, for example AAB, we just started doing the same 1 and 1, I mean A and A match. Okay, then we will match the second character of the pattern with the second character of text. There is a mismatch, so what we do, we will shift by 1. So the entire AAB will be shifted by 1 ahead. So we do like that, s equal to AA. Okay, we just shift by 1. So s, the first character become A, and here it will be the C. So there is a mismatch. So again we will shift AB, and we get at s equal to 2 there is a valid match. Okay, so this is the simple algorithm, naive string matching algorithm. Similar here we can match. Okay, like that. Okay, the pattern is ABAA, and there is a string, I mean text AB. So in such type of, if a question asks just by using a Rabin cap nav string match algorithm, so we just have to show at how many shift the first match is there. Okay, how we can find the first match. Okay, so just like that. Secondly, Rabin Karp string match algorithm. In this we use the concept of hash functions. So we have already seen that the time complexity, if we just use by Rabin car per nav string, there is a n minus m plus 1, order of n square almost, or you can say order of n into m, okay, approximately, or more appropriately it is order of n minus 1 plus 1 into n, okay. So next is string matching with finite automata, okay, how we can match with the finite automata. So let's have some concept of by using finite automata and KMP, Knuth-Maris-Pratt algorithm, the time complexity of this match becomes order of n, okay. So that will be more preferable. So just see the process how we could match the pattern with the string by using finite automata. Let's have the concept of automata. So a finite automata is what? A 5 tuple, okay, like q sigma delta q naught f, where q is set of state, sigma is set of alphabets, okay. Delta is what? This is transition mapping from q to sigma, okay. And transition mapping q and sigma, state symbol. Q naught is the initial state and f is a final state, okay. Like here q is what? Set of alphabets, so 0 and 1. Sigma is what? Q is what? Set of state. So we have, for example, here 2 state, 0 and 1. 1 is final state, okay. And set of symbol or input is A and B, the string, okay. So how we can make the transition diagram, transition mapping, how we do? For example, in the given diagram, we have seen like delta 0 from 0 comma A means what? From 0 state, and if the input is A, where we are going to reach the 0, and if we give the input at 0 state, we can reach on 1 state. Similarly, delta 1 and input, while input A we are going to reach 0, even delta 1 and B we going to reach 0, okay. So by using finite automata, we just use the concept of finite automata, which is 5 tuples, okay. Finite automata is a 5 tuple q sigma delta q naught and f, okay. So this is the algorithm T, where n is length of text, m is length of pattern. So what is the process? Let's see with the example. For example, P is given A B A C A, and this is the pattern and this is the text. Find the pattern P in above text using finite automata. So what is the process? The process, we just find the longest common prefix, okay. So for example, see here, how we find, have to make finite automata pattern. The process is how to make the finite automata pattern, and the concept which we use, two concepts, prefix and suffix, are used to make finite automata pattern. For example, this is the string. So the prefix of the string is like AAB, which is start from initial AAB, ABC, ABCD, and the suffix always start from RHS. If we want to write what could be the suffix of this string, so this could be from the RHS from the last. So this could be C, BC, ABC, like that. So we have seen if there is a prefix ABC and suffix ABC, so at prefix and suffix both are matched. So this point could be the decision point, okay. So here prefix and suffix match, so there is a decision to make finite automata, okay. So what is the process? The first we have to identify how the prefix and suffix is going to match, okay. So for that we make the finite automata. So the process, just say, we have to find the how many characters or alphabet in the pattern are given. So we make that many states, like we have 1, 2, 3, 4, 5, 6, 7. So we just make 7 states, 1, 2, 3, 4, 5, 6 and 7, and 7 will be the final state. Okay. Out of that we have just made initial state 0. Okay. So let's see how we proceed. So here m becomes number of character in the given pattern are 7. So there will be 7 state, I mean 1 to 7 and 1 initial state. So total there will be 8 state. If the pattern length is 6, so there will be 6 state plus 1 initial state. Okay, so just by putting input from state where we could reach, for example, A, B, A, B, A. So let's see, we have at initial state say 0. Okay, so if we give the input A, so we come at A, I mean A. So 0 to 1, we can reach this. I mean, let's see, we will see all 3 symbols. There are 3 symbols A, B, C. So we will see all 3 symbols A, B, C at all state 0 to 7. So if there is a, I mean, match, I mean, just we have to see the pattern. So if the string change in the, I mean, in this finite state, then we will make new state. Okay, like 0 to A. So string is A. Okay, so it will reach at next state 1. Similarly, by putting B, 1 to B. Okay, so we are going to reach A, B. So A and B. Okay, so there will be 7 as 0 to initial state, final state. We will see all 3 symbol. We will see all 3 symbol A, B, C at all state. So from 0 to all C symbol, if we put A, first value A match with the pattern, so we will change the state. That's why it become the 1. 0 to B, there is no match. 0 to C, there is nowhere to go. So no state will be changed. Now from 1, I mean next state, if we write A, so what will be there? AA, there is no, I mean prefix which is going to match with the pattern. Okay, so what will give? It will be AA, prefix A and suffix A match. Okay, prefix A and suffix A match. Suffix, I mean last one is A. Okay, so if prefix A and suffix A match, so 1 to A is 1 to A, I mean we are going to reach at A. Okay, so see AA, I mean if prefix A suffix A match, so we will reach at just same position. So it is 1. Now from 1 and having input B or symbol B, what this thing could be? AB. What will be? AB. AB, yes. So it is just going to match AB in the pattern. So next state will be 2. So either if we match with the pattern, or the second one is what? Prefix and suffix match, like in the case AA. Okay, so that point will be of decision. Okay, so what will A be in the pattern? Next state 2. So whenever we are just going to match the text, we will write the next state. So that's why next state 2. If at 1 to C AC, there is no part of AC is not part of this, so we will just leave. Not in the pattern, no prefix and suffix match, I mean AC and there is a CA. So there is no match. If suppose this becomes C and here it's all become A, so then we would have AC. So we could reach at second position, but it is not the case. Now from second, we will put all input A, B, C and see where we go. Okay, so ABA, yes, ABA, we just get the, so there will be new state and we will go up to the third state ABA. But if we put the input ABB, no prefix and suffix match, ABB is not the part of pattern, and ABB is nowhere prefix and suffix. Okay, ABB, but here ACA. If we just calculate the 3 length suffix, this become the ACA. So there is no match, so no point to discuss. So we will leave that state. Okay. Similarly, from third state, I mean from here where the string become ABA, and now from third state we will see all 3 symbol ABC, ABC. So from ABA, okay, if we input B, it becomes ABAB, it becomes ABAB, ABAB, yes, there is a match. So we will put the next, I mean state, that becomes the 4. So by this way, this is the process, and at last we will reach at the complete, I mean this one, ABAB ACA. Okay, so by this way here, okay, so no prefix and suffix match, so no transition. And where we from 6 to ABAB 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 ACB, okay, ABAB ACA. Okay, the prefix AB and suffix AB of length 2 match, so transition from length 7 to, I mean this transition from 7th state to 2 length match. So the figure, okay, so by this way we could I mean we could find the transition. Okay, okay, so now what we do by this, I mean this is the transitions, okay, and out of that then we can make the this table. I mean we have last is what, 7th, okay, this one is 7th, and 7 is the become the 7 is the final state. Okay, so when we reach at the final state, then we stop doing. Okay, so by this way we can find the match. Okay, at this print q equal to, here q equal to 7 equal to m, so we can print occur with shift I minus m. Okay, so in finite automata what we do, first we have to find the pattern length. Depending on the pattern length there will be that many states. Okay, and by just from every state, by putting all symbol, we will see where we are going to reach. If we get the match with the pattern, then we change the state. Okay, and or even the prefix and suffix match, then we also change the state from that state. Okay, next and the most important, I mean string matching algorithm is Knuth-Morris-Pratt algorithm. Uska time complexity is order of n. Okay, so in this we calculate pi tables, pi value we calculate. So what is the process? So KMP is a linear time string matching algorithm run in order of n. KMP uses concept of prefix and suffix for generation of pi table. So we have already introduced the concept of prefix and suffix. What is prefix? Prefix always start from LHS and suffix always start from right side. So if you are just going to find the prefix of say this string, so this become A, AB, ABC, ABCD like that. If you are going to find the suffix of this, I mean pattern, so this become the C, BC, ABC, D, ABC like that. Okay, the prefix is always counted from LHS and suffix always counted from RHS. So do we get prefix and suffix same anywhere? If it is so, imply that the decision making value for pi table. So how the pi table is going to calculate? What is the pi table? So pi table means longest prefix that same as suffix, LPS, longest prefix that same as suffix. So what is the pi value? Because it is used in KMP for the matching. So how we calculate? For example, this is the text or pattern. Okay, so just we put the numbering 1 2 3 4 5 6 index on the text. Okay, so if there is no match like A B C D, okay, A B C D, I mean A, so we just, this is the first character, we just write 0, B, okay, so this is 0, C, D, there is no, I mean they all are just new, so we just write the pi value is 0. Now here comes A, so A is already there, so we write the index of this A here all into here on this position. So this one, and B 2 2, okay, E just come new, so it is in its pi value will be 0. Again A is already there, okay, so it's become 1. AB, in fact the whole, so AB we just get 1 2. F is new, so we put 0, okay. So this is the pi value of this pattern, okay. Now similarly we can calculate the pi value of this text A B C D E A B F A C. So first of all we just index the pattern, okay. Now we just index means 1 2 3 4 5 6 7 8 9, okay. A has come just once, or we can say A as a new, because there is no alphabet, so we just write 0. This is B is also new, not yet not come before, we just write 0. Similarly for C, just as a new, so 0, D 0, E 0. Then A is already there, so we just write the index of this A, that is 1 here. Similarly B is already there, we just write the index 2. Then F just come new, so its index will be 0. A, in fact A B C, so we just we get, I mean this prefix is going to match with this suffix, so we write 1 2 3. So we put the index if it repeats, I mean if it is prior in the pattern, then we put the index of that become the pi value. Next example of pi value, like A B A, like that. So first we write the index, I mean the length, okay. So 1 2 3 4 5 6 up to 9. Now how we can calculate the pi value? A has just come, I mean A is a new, so 0. Then A, already A has come, so we put the index of this here 1. Then again A, so A is also here, A is also here. Which index should we going to put? So we just find the longest prefix which is matched with the longest suffix. So suppose for this A, so if you want to calculate the prefix, longest prefix, this become AA, and the longest suffix will be this AA, I mean say AAA, and this index is like 1 2 3. So this pi value will be 0. A will be what? Already come 0, then 1. We just find the write the index of this A. And now this become A. So this could be this or this. Okay. So what we see? We see the longest prefix and the longest suffix. So up to this string, this will be the prefix, and for this will be suffix. So AA, I mean 1 2, so there becomes the 2. Similarly here 3, so 3 string 1 2 3 and suffix is a 2 3 4, so there becomes the 2 3 4. Okay. So by making the pi value, okay, KMP works on the pi value. Okay. So this is the algorithm how we calculate. Here I think we have, okay. So this we have written the process. Okay, we just go through and you will find the match. Okay. So just in string matching, what we do, we just find the longest match. I mean So that could be done by 4 algorithm, either by Navy string matching algorithm or round Robin cap string match algorithm or finite automata or Knuth-Morris Pratt algorithm. Okay. So just go through the notes and you will find steps are written. You will get the all right thing. Okay. Okay. Thank you everyone. Jai Hind.